Muhammad Umar Farooq biological video. Please make sure to subscribe, like and share. Ask the question for answer and comment about the artwork. You can also answer question to each other for solving the problem. Now here we will discuss about the mechanism of breathing. That is the mechanism of inhalation and exhalation of gases into the lungs for respiration to provide the oxygen and exhale the carbon dioxide. So the gas moves from area of higher pressure to area of lower pressure. So that's mechanism is due to the inhalation, due to the a change of pressure of the gases inside as compared to the outside of the environment basically. So here all discussion about here we will discuss everything about the inhalation and exhalation, the mechanism of inhalation. So here is the person which does contain a trachea and lungs. The breathing mechanism is depend on the trachea, mouth, nasal cavity and lungs, and this lungs is further divided into the basically divide into the bronchi and alveoli and alveolar sac. So here is the person which that's contain lungs, and that's lung is surrounded by the basically lungs is surrounded by the ribs, is known as rib cage, and there the rib is attached with the sternum and backside from the vertebrae. So here the atmospheric pressure is 760 millimeter of mercury. That is the atmospheric pressure of the gases. So we will discuss inside. Basically the normally when breathing is equal, that is inside is also 760 millimeter of mercury. When changing of the pressure inside as compared to the outside is triggered the movement of air inside or outside into the environment for using the oxygen dissolved into the tissue. So here is the increased pulmonary pressure. It means the pulmonary pressure will be increased to move the air outside when lungs will be contract. So here important to know that the intercostal muscle is also present, attached by the pleura. So there's a visceral pleura is inside, and that is the basically outer membrane. Visceral pleural membrane is present, and parietal pleura is the outer layer of the pleural membrane, that is the outer parietal pleura. On the other hand, between the visceral and parietal, that is the pleural cavity. That pleural cavities protect the lungs for the movement, and that is also filled with the fluid, interstitial fluid. So now we will discuss briefly about the mechanism of breathing, and that's the contraction of the intercostal muscle and relaxation of the intercostal muscle, which that is surrounded by the lungs with attachment of the rib cage. So when interpulmonary pressure, it means the inside of the lung the pressure is something. So that's if interpulmonary pressure will be equal to 760 millimeter of mercury, so the difference of the pressure is zero as compared to the outside of the environment. So that's important to know about that. So when move the oxygen inside, it means the pressure will be decreased inside. So the decreasing of the pressure of the pulmonary pressure inside is 759 millimeter of mercury to allow the movement of air inside. So here I am drawing the lungs which contain a rib cage, and that is the intercostal muscle is attached with the lungs. So here is the pleural cavity which that is surrounded by the parietal pleural cavity, parietal pleural membrane, and inside is the visceral pleural membrane which that is middle is known as the pleural cavity which that contain a fluid. So this mechanism is here which that is the diaphragm, that is the down basically thoracic cavity which that is covered by the diaphragm's downside. So the lung is present in the thoracic cavity because it's present into the thorax region. So that's here is the intercostal muscle, and that's the diaphragm is made up of also muscle. It's depend on the relaxation and contraction of the diaphragm to give a breathing mechanism. So now discussing about the interpulmonary pressure and atmospheric pressure. So let's talk about the whole mechanism. So the intercostal muscle is contract to breathe out, and when intercostal muscle will relax to breathe in, it means the inhalation, and exhalation is known as the expiration, and inspiration means the movement of gases inside of the lungs. So here's the interpulmonary pressure will be equal when there's a breathing mechanism is stopped. So the exchanging of the atmospheric pressure, which that is measured by the mercury, millimeter of mercury, that's the basically measured by the pressure of millimeter of mercury. So that is known as the pressure. Atmospheric pressure is 760 millimeter of mercury. But on the other hand, inside the changing of the pressure into the lungs is depend to inspiration and expiration. So here is the rib cage which that is attached by the vertebrae, and that is back side of the vertebrae, that is, and sternum which that is contained attached with the cartilage, and that's surrounded by the attached by the intercostal muscle, and this intercostal muscle is attached by the pleural membrane. So this pleural membrane which that is allowed to move of the lungs. So here is the cross section of the rib cage which that is also present the pair of the lungs, left and right. So now important to know about that. Here is the lung which that is, now we will discuss about the inspiration. So the inspiration means the gas move into the lungs. Why? Because inside the pressure basically interpulmonary volume increase, and that's the increasing of the interpulmonary volume to decrease the interpulmonary pressure. So the increased pulmonary intrapulmonary pressure when decrease basically, so it means the 759 millimeter of mercury. So the negative 1 millimeter of mercury will be responsible for the movement of gases into the lungs. So here is the interpulmonary volume increase. So the interpulmonary volume will be increased to intrapulmonary pressure decrease. So the decreasing of the pressure will move the air inside. Air moves from higher to lower pressure. So important to know that. So what happened in this mechanism? That is the diaphragm will be expand, and that is the sternum will move upward. It means the expand of the diaphragm for creating the volume more for inspiration. It means the gases move inside. It's not depend on the just oxygen, it's depend on the nitrogen, oxygen as well as carbon dioxide. But the maximum amount of oxygen will move inside because the inside is the less amount of oxygen is present during the inspiration when delayed the intercostal muscle. On the other hand, the diaphragm will move downward, so that's a less dome like structure. So here is the expiration. Expiration means the movement of gases from inside to the outside by the creating a more pressure inside as compared to the outside. So that interpulmonary volume decrease, the interpulmonary volume will be decreased, its the volume will decrease, so the intrapulmonary pressure increase. So the intrapulmonary pressure will be increased from the one more positive 1 millimeter of mercury. It means the 761 millimeter of mercury will be possible, even more. So here the air moves out down the pressure gradient. So it means the air will move outside into the environment. It's not just only carbon dioxide but also oxygen and nitrogen as well. So here we are taking just carbon dioxide and oxygen. So here is the basically diaphragm will contract, and that muscle will be contract and intercostal muscle will be contract, and that is the shrinkage of the rib cage due to the sternum, and that will create the expiration. So this all is about the contraction of the intercostal muscle diaphragm. So the diaphragm is more look like a dome shape. So that's important to know about that. Now we will discuss about the side view of the inspiration. During the inspiration, so that when oxygen will move inside by the creating a less pressure inside, to move diaphragm is downward, is less dome like, and so that the diaphragm descends. Intercostal muscle contracts, and that is the rib cage rises. So it means the intercostal muscle will be contract. So when breathe in, so the intercostal muscle will be contract. So the contraction of intercostal muscle to move upward the sternum. So important to know that the contraction of intercostal muscle is during the inspiration, not expiration. So previous talk is not really comfortable for you. So here is the important to know that the external intercostal contraction. So it means the external contraction will be possible. So diaphragm descends, intercostal muscle contracts, rib cage rises. So the thoracic cavity volume increase and interpulmonary volume also increase, and that is the volume also increase, and decrease interpulmonary pressure due to the decrease interpulmonary pressure. And during the expiration, that is the meaning of exhalation of the gases, during the relax of the intercostal muscle, as well as decrease the rib cage and sternum will downward, as well as the uh, diaphragm muscle which that is relax basically. So that is the meaning of this, that is the relaxation of the muscles will allow to move the carbon dioxide outward. So the diaphragm rise, intercostal muscle relax, rib cage descends. Thoracic cavities decreases, interpulmonary volume decreases, so it means the interpulmonary volume will decrease, and interpulmonary pressure increase, so the pressure will be increased. So the increasing of the pressure allow to move the gases outside into the environment because the pressure gradient will be created from inside is more as compared to the outside. So the balancing, it's used for the balancing, so the balance will be created. So what is the important to know about that where is a gases is stored or where gases move. So here I am drawing the lungs, which that is contain a basically larynx, cartilage, and trachea. So this larynx, cartilage, trachea is here, which that is meaning is here is the bronchus. So this bronchus is basically further divided into the bronchule, and this bronchule is also basically further divided into the alveoli, bronchioles to alveoli. So here is the internal pleural membrane is here, and there's a pleural cavity which that is between the external pleural membrane and internal pleural membrane, and here is downside is the diaphragm. That diaphragm is made up of muscle which that is result to the contraction of and relaxation to move out the breathing out and breathing in is due to it. So here is the alveoli which contain alveolar sac. So these alveoli is contain a carbon dioxide which that is come from the heart when heart will pump the pulmonary artery which contain deoxygenated blood, and that's bathed by the gases which that's come from the during breathing, and that's oxygenated blood come back by the heart.